So I just want to take a couple of minutes to talk through a couple of these common patterns. I'm not going to spend too much time, but just kind of list them out here. I think if you spend some time after this digging into some of these patterns, seeing what patterns you've maybe implemented in your own area, or how you might also learn new patterns that might be usable in the future. So I'm not going to dig into all these, but just these are kind of the most common ones that we probably all have encountered or used day to day. So when I think about how do I solve a really hard problem, it's not so easy, right? How do you approach something that's so big or so difficult or so complex that you haven't done it before? How do you approach that? And I came up with this idea of these like layers of of a cake. How do I even break this problem down? Because sometimes the problem is like so big, it's just it's unfathomable. And when somebody comes to me with like an answer of like do this thing, I still feel like it's important to look at these different layers to try and make sure that you're coming up with the best and the most appropriate design. So starting at the bottom and then working our way up, I think first about what is the problem statement. So what is the problem that we're trying to solve here? You know, somebody can say, hey, Amber, go implement this technology. And I'd be like, okay, I can go do that and I can go do it. But if I don't know the problem I'm solving, I don't know if I'm successful at the end. Did I do the right thing? Did I build the right thing? Did I set it up the right way? I have no idea. But really understanding what is the problem I'm trying to solve here. And then I can validate that what I did was right. So at this point, really, I'm trying to stay super high level. I maybe say that problem statement in maybe a paragraph or two. It could be something very basic like, hey, we need to meet new privacy regulations for GDPR. And, so how do we do that? That could be the problem statement. Or it could be something like, we want to increase our consumer base. It could be something as simple as that, or even more specific of, hey, we're having issues with our database. We need to have a new solution for improving performance of our database. So kind of all different ways to come about what a problem might look like, but it should be pretty high level and pretty high summarized. Here's an example of a problem statement here. So if we were to think about, hey, I love animals. I absolutely love animals. In fact, that's my dog Wolfgang there in the tie. He's a very, very majestic. I want to be able to borrow and share pets with others. So I have a dog who loves to be around other people, and he really wants to spend time with other people. Or I'm a person who I don't have pets because I'm not allowed to have them in my apartment, but I sometimes want to borrow somebody's to go play with them in the park. So this is a problem statement, pretty high level. The next thing we want to do to build upon that is establish some business requirements, is understanding what exactly are the requirements that we're trying to solve here. And these could be in the form of feature requirements. It could be in the form of use cases. Oftentimes there's phases to say like, here's the MVP and different phases that we need, any kind of constraints. How much money do we have to spend? How much time do we have? Different things, how many people do we have to solve this problem? All those different kinds of things. These would all go into business requirements. So in my example, I'm building Ferber, which is a pet sharing app. And our actors here are pets, pet parents, and pet petters. That is a mouthful. I always mess up saying that. But these are the actors in our system here in my example app. And our business ask and use cases in this example would be that we want to list pet availability. We want to schedule some petting time. We want to be able to offer ratings of the pets, and of the pet petters. How did they go? Were they nice to our animals? Did they bring the animal back clean? Have some filters and recommendations, be able to share photos. So if you can imagine a pet sharing app and all of the possible business asks, here's that list of them. And then on top of that, so we have our problem statement, our business requirements, and now we add our technical requirements, or the ilities. So these are just a list of a few abilities that I found. But these are really the technical requirements. They're not necessarily the things that the business partner, the product manager is going to ask us to do, but they're the things that help us ensure really robust design. And now you're not going to be able to, you know, like think about all of these, but I usually pick a handful of the ones that mean the most to me in that context of that project. For example, these are the ones I probably consider almost every time, along with some others, but these are the ones most often. So maintainability, can I support it? Am I automating everything? Is it reproducible? All of that makes it really, you know, something that we can go to production with really easily. Is it highly available? Is making sure that I have HA or DR if that's a requirement, that it's scalable, that it's not just a single instance that could go down, or if we need to scale after a big spike in Rihanna tweets, we want to be able to grow it exponentially. So consider how do we do that, and then observability, how are we monitoring and alerting, security, of course, maybe that should go up on top rather than down here at the bottom. These aren't in order of preference, but really making sure we meet compliance. So if we're taking payment in order for people to pay to share their pets, then we might make sure that we're protecting payment card data. And then we want to think about performance too. So if we do get that huge spike of Rihanna followers who come to our site, we want to make sure everybody's experience is just as good as people if there's only 10 people on the site at the same time. So anyways, then next, so we take all of those things and we add on then patterns and standards. So I mentioned some of the patterns earlier on. You might also have patterns within your company or organization, some best practices, some standards, and that could be anything from like, how do you do monitoring and logging? How do you do distributed tracing? These are oftentimes these things that are like ubiquitous across everything, that you don't want to have a separate monitoring solution for every single thing. So if you have, you know, 10 different services, you don't want to have to look at 10 different dashboards to figure out what's going on. You want that consolidated. You want to be able to have consolidated authentication, error handling, all those types of things, as well as backup snapshots, et cetera, et cetera. So there's just, you know, like these are just a few of the examples, but having the consistency in things to be able to say, I don't have to solve this problem over and over and over again. I have kind of a standard way of doing this. Another best practices and standards to think about is, I listed just a few here, is API contracts. So if you are using API interfaces to define the services, then that's fantastic. And having consistency in how you're doing that and making sure you're publishing that so people can find where those API contracts live. Maybe you have standards around what technologies are used, as well as what third-party partners you have approval for, all sorts of different things. And then I put it in documentation, of course, but I put it all in caps, naming, because naming is so important. I can't stress that enough. Naming. Always think about how you're naming things so that people can find what they need, that it makes sense, that you're naming things that are not cute names, but really more functional names, etc. So all of these things are really best practices that are unique to probably your company. You want to think about all of them. All right, so we have our 4 layers of our cake. We've thought about all the things. And then on the side of those, we want to add in our constraints and our feedback. So we want to think about what are the constraints that we have. I mentioned a few earlier on, like our budget and our time and how many people we have to work with, and then get feedback all along the way. So we want to continue to iterate on all of this and make sure that we're getting that the feedback all along the way to say, are these the right the SLAs? Are these the right SLAs that we've established? Does this make sense? Okay. So now on to really overcoming the complexity when we're solving really super hard problems. This is a picture of Karen Milavec. She won the 2019 Abel Prize, which is kind of like the Nobel Prize of math. But she clearly knows how to solve really hard problems. Now, where do you start when you have this really complex problem? I talked about some of the things we want to think about when we're designing. I made up this really easy to remember, really easy to say, ABUBUF acronym. And that is to understand, break it down, brainstorm, and feedback. So the first thing is to understand the problem. So understand those requirements, go back to the dimensions of the architectural design, really make sure that you understand all of the features that were talked about by the business team, that you understand all of the technical requirements, that all of that really is well understood. That's super important, right? And that you understand the problem statement. If you don't ask a lot of questions, then this is your chance to ask a lot of questions. And then next, to break it on down. So really complex problems, you need to find a way to break it down into bite-sized parts. So, with the Ferber example, for example, trying to say, oh, we're going to create this big pet sharing app it's a lot. That's a lot of things to consider when you looked at all of the requirements that I had. But how do you break that down into parts that then can be built in isolation and then plugged together like Legos? So one way of thinking about how to do that is possibly using domain-driven design, and that is to break down functions within the requirements into pieces that are called domains. I'm not going to go super into domain-driven design. There's really a lot of great books out there. I can also, share some things with you at the end as well. But just to think about different ways of breaking down problems into like more bite-sized chunks and then solving within those bubbles. Then next is the decision making. So once we've broken it down, we then brainstorm ideas for, we take our component, we start breaking it down and brainstorming how do we solve that problem. And along that way, we're going to continuously get feedback. So brainstorm and feedback, I feel like is these two pieces that are going to work really closely together. And I kind of drew it like almost a circular arrow, because you don't just go through step 3 and step 4 and stop. You're going to probably circle this around a bit. And this is part of that facilitating and negotiating piece of being an architect. That is sometimes like one of the longest parts of the job. It takes you less time to maybe design the solution as it does to kind of get everybody on the same page, making sure they are also understanding the problem, making sure that they understand how things will work together, and incorporating their feedback. So if they say, oh, hey, I have a better idea. We already did it this way. Here's how we can do it this way. So incorporating that feedback, and then you loop it through, and then poof, out pops the solution. Like magic. Not really, there's a lot of work, but. Okay, so how do we then document that design? We want to make sure that we've then come up with the best solution. We've looked at several options. We've considered all of our requirements, and we want to then share that, not just with the people who are going to build it, but also probably going forward with, like, historically, any new people who come and join the organization. This is almost like the documentation, the paper trail of what was designed and what was built. I think every company calls them a little bit different. So at the last company I was with, we called them high-level designs. At my current company, we call them technical design documents or TDDs, whichever. It doesn't really matter. And there's probably different formats and ways of documenting them. But I think that the elements are kind of similar no matter what, which is where you're restating those things that we talked about with the architectural dimensions of the problem statement, probably linking out to the requirements and the use cases, all of those things. But this is really a way to document that final solution design. We're going to include probably a lot of diagrams that show in pictures, not just in words, what it is that we are solving. It's going to include how we're going to specifically meet the ILITs. I saw someone ask what SLA is. I'm sorry, I didn't define that. Service level agreement. So if we have uptime requirements, how are we going to meet those uptime requirements? How are we going to meet the response time requirements? So all of that would be in there, as well as like any kind of gaps, any kind of phase releases that might be done, or any open questions that might still exist. So this is kind of a consolidated document where you're able to list all of that information and share it out. quickly, I want to talk a little bit about how you draw diagrams, because I think this is something that is something that takes a lot of practice, and is something that I'm always working on to get better and better at, and is something that's really important for communication, because not only do we have to communicate things both verbally and in meetings or discussions, but we want to actually have that visual representation. And some people really can learn and understand things via like paragraphs of a description of technology, and I for sure really benefit from also seeing pictures that show how things work and fit together. That is super valuable to me. I think it is super valuable to a lot of people, actually. But what makes a good design here are really the ability to be consistent, concise, clear, accurate, and then also thinking about colors and a key. And a little bit of a reason why is that I really mention colors because I think sometimes I get really excited about colors and I want to use a lot of colors, but then it confuses people, like, why are these colors and not these colors? And if you don't include a key, and then it's like, okay, I've just made it worse and more confusing. So you don't want to do that. You want to really be considerate about that, as well as think about, there may be people who have visual color differences. So they might be colorblind and not be able to see certain colors, and think about really what colors you do use that makes sense for what you're trying to show. Okay. So from just like a high level, where do I even start with the diagrams? I think that sometimes like you're not really sure, you try to put everything in one picture. I try to like really think about things from this high level drilling down kind of visual. And I love this picture of a moth, looking at the moth, and as you drill down you can see like the little components of its wing, and then you dig down a little deeper and you see little ridges within the components of and the ridges within the ridges. And I think that's just such a beautiful way of looking at how do we describe our solutions in a way similar to that. So starting really high level, that would be something that you might share out with senior leadership and explaining a problem on a really high level, and then down to that lowest ridges within ridges of the moth wing to show physical deployment documents. So that's really down to like how you do clustering and how you do maybe multi-region or all the different really deep technical physical deployment. So I'm not going to go into these too much, but just wanted to show some examples of, from our Ferber example, we're going to stick to the Ferber example, from a super high level, conceptual level. This represents really ideas, not specific technologies yet. We're going to have a calendar. Someone can register and pick a pet on their calendar, and then save it and then rate them. So this is a very high level how that would work. Logically, then we're taking then a step a little bit deeper, and we're looking at maybe the services and components that make up those different conceptual components, and maybe show a little bit about technology here. Usually one box equals one system, not necessarily, but it also is going to show how things interact with each other. And then even a step deeper, this is the ridges within the ridges on the moth wing, and that's the physical deployment. So you're looking at maybe in this case, infrastructure components that include a load balancer, how we're doing the replication, how we're setting up the network, all of those kinds of things. And of course, probably senior leadership is not necessarily going to want to see this particular document. This is very, very valuable to the engineers, though, who come after you, who want to know how something was done and set up. So, and trust me, like, you will get better with practice. So the more you draw these pictures, the more times you go through them and share them with others and get feedback, you will get better. This is like examples. This is an exact one, but this is examples of maybe what some of my earlier diagrams look like, but they're pretty bad. So you'll get better. So this is the last section, and then I'll have some time for some Q&A at the end. But this is really, I want to talk about evolutionary architecture, and that is, instead of being in a world where you have to do all this planning and figuring out how you're going to solve all the problems and all the phases and anything that might ever come up front, and really doing things in a way that allows you to be more agile. I think probably most of us, maybe not all of us, work in a more Scrum or Agile based model where things are going to change, and you have systems that should be flexible and malleable with that. So thinking about upfront, how am I designing in a way that is flexible? I have a recommendation for a book that's pretty good that talks about this in depth, so I'm not going to go too deep into here, but really thinking from a high level, how do we reduce dependencies, leveraging some of the standards that we talked about before, and creating more agnostic architectures it talks about, and then domain-specific architecture. So I think this is a really great book if you want to check it out. Some of the things that I like to think about when I'm really making sure that what I'm doing is agile and more flexible in the long run is to really think about small changes and to think about phased rollouts. Not trying to do a big bang change into something unless it's like there's just some huge necessary need for it that you have to do a big bang need, but really think about how do you make smaller changes. Trying to decouple things whenever possible. So if you have things too tightly coupled to the same database, pull it out and give each thing its own data store so that this can then change and move and you can eventually decommission this old one. Looking at different ways of creating anti-corruption layers and preventing vendor lock-in by having kind of services in front of vendors so that then you can plug and play different vendors behind those services, but the API itself doesn't change for your internal users. So things like that will help you be more iterative and evolve easier over time. And then super quickly is thinking about how if you have a monolith today, in order to move towards a place where you can be more loosely coupled and more agile, would be to figure out how you can decompose that monolith into smaller parts. And this is really as much of an art as it is a science of really figuring out what's the right way to do that for your particular services or set of services, how performance impacts your systems, where your bottlenecks are, and thinking about all of those things. And there's a good example here around just kind of your basic e-commerce website. And I linked to the article here because I think it talks through different ways of doing it well and maybe some ways of maybe avoiding pitfalls. So this is a great article to check out a little bit more about how to do this well. All right, so what next? You've sat through 30 minutes crash course on being an architect. What are you going to do next? I think taking the next step to becoming an architect or to wearing the hat, because like I said, it can be just a function of your current job, is really to just start doing some of these things, is to start designing out what it is that your current system does, drawing those pictures, talking about how improvements could be made, where your bottlenecks or your issues are with support. What are some things that could be improved, and then pitch that. And really understand that you don't have to know everything. I don't know everything. I'm always asking people questions about how things work and how they fit together, especially being at a new company. I definitely don't know everything there. So knowing that it's okay not to know everything and that you can ask a lot of questions. And sometimes you can shadow an architect if you work at a place where there are architects, and learn from how they do things at your company, I think is really helpful, or seeking out a mentor, if not at your company, out in the community, who can help you with this as well. When I very first started as an architect, I asked for a stretch assignment. So that's something that maybe your company would allow you to do as well, is to just like ask to partner with somebody, an architect, or to work on an assignment to do that. And then lastly, just do it. Just like I said, just start pretending you are the architect for your area and thinking about all of the ways in which you can make your system better. And then just being the person who asks a lot of questions and making sure you understand it is just really, really vastly important. So here is my contact info. I would love to open up the, I think there were a lot of chat questions and comments and stuff, but I would love to open up to questions. If anyone has any? I can start looking at some questions in the channel.
Yeah, do you want them to read it from the channel, or would you like them to unmute themselves?
Well, let me look in the chat really fast. Well, the slides we share, I will share them for sure. Oh yeah, I can share it. Okay, so can I share tools used to draw the designs? I think is what maybe someone's asking. For me, drawing designs has been historically, like I evolve over time in what I use to draw, because I almost always start on a whiteboard on a piece of paper with my brainstorming. That's always really my first thing that I always do, because I just want to get things out really quickly, and that's a really quick way for me to do it and play with things. And then next I'll take it to either Omnigraffle, which is a Mac specific tool, or Lucidchart, which is a web-based tool for design. I like both of those. So I recommend either of those, and that helps you with some of they have some great templates and some stencils already that you can start with. So I recommend those. Some people like to just keep it really simple and just use like PowerPoint or you know, some sort of slide technology. That's fine too. Let's see. To be an architect, is it a requirement to be a developer first? I would say you don't necessarily have to be a developer, but I would say that it's really important to have hands-on technology experience. Because I think being able to know how to solve a problem, having solved it hands-on before, is super important. So I mentioned that there's like kind of specialist architects, and some cases if you are, if you're like say coming from the database world, or maybe data science world, or machine learning, you may not necessarily be a software developer, but you have other technology experience. I think that's also a great way to be an architect of that specific type. So hopefully that answered SV's question. And let's see. Oh, somebody has a lot of good questions. How about we just we open it up to the to out loud questions, if anyone has any.
You guys can unmute yourself.
Could you repeat the name of the tools you just mentioned? I couldn't hear them.
Sure. So Omnigraffle, that's a Mac-based tool, and then Lucidchart. So Lucidchart is a website, and so that enables collaboration and sharing, which I like a lot. But both of those tools are really good for doing design documentation.
Thank you.
Yeah.
How often in your day-to-day do you code often?
Yeah, so I think it depends. I think what I'm doing a lot is, I wouldn't say every day am I coding, but every week I'm coding. So it depends on the week. Some weeks I spend more time doing proof of concept, so I'm doing a lot more coding, and then other times I'm doing a little bit more selling of the designs and gathering requirements or research. So it depends on the week, but I would say almost every week. Because I started a new job back in February, I've done almost nothing but hands-on stuff for like the first 3 months, just to kind of understand how everything works at the current job, and actually doing a lot of coding just to get my feet dirty here. So I'd say it evolves based on the week, but I'm not usually the person pushing changes to production. I'll say that I'm more working on earlier phases of the code. So looking at proof of concepts, playing with new technologies, definitely doing code reviews. So looking at what other people's PRs are. So.
Hi, I really enjoyed your talk. I was wondering if you could recommend any reading for demand-driven design. I've been reading Eric Evans's book, but if there's anything else that you recommend.
I will share some with you. I can't think of the author right now off the top of my head. I will share on the meetup page.
Awesome, thank you.
Yeah. Yeah, I meant to include a link and I forgot to do that. I'll make sure I grab that.
How do you go about doing like proof of concept? do you already know how the system like works and then try to build something, or is there a different way to go about it?
I think it depends. So sometimes you'll build a proof of concept because you're just playing with a new technology, just in isolation. So it really depends. So I can give a couple of examples of in my last couple of years, but I've done proof of concepts, everything from playing with different vendors. So when I'm doing vendor analysis, if I have to work with a third-party vendor, I'll do kind of a little, a mini proof of concept of what we might do on a larger scale, but I will do it to see what do I want to know about that vendor. So do I want to test their features and functionality, or do I want to test their performance? So the proof of concept will be based on what I want to know, right? So I want to test what concept. And then I will say sometimes it is as part of a bigger, like an existing system. So if I want to see, oh, if I were to integrate this other thing into the system, how would it impact performance? I might do a little test to see how that will affect it. So that might be, I'm going to do it in, off on a developer environment, not obviously in production or anything, but I want to see what the impact to performance would be by me making this kind of addition to the system. It totally depends. I think what matters most is that you're defining the concept that you want to prove, right? And thinking about that. It's like, am I wanting to prove that it works, or am I wanting to prove that it works fast? Or, like so many different things you want to test out.
Hi, Amber.
Hi.
Hi. Yeah, it was a great session. I really enjoyed it.
Thank
and
you.
I love the background that you have. It's pretty playful.
It's very summary, yes.
I'm a product designer, like a user experience and interface designer. And I understand that feedback plays a super important role to sort of improve any product. My question is that you said that the more you share, the more better it gets. I agree. But then at times there are like various feedbacks from different people, various perspectives. So how do you deal with that situation when you have to sort of negotiate?
You mean you get feedback that you don't want to accept? That it's, yeah. I mean, I think that's going to be the case where you are sometimes going to get somebody who has an idea, or I mean, I guess real life example is you could oftentimes have people have two different ways of solving the same problem, because there are always multiple ways of solving the same problem. And eventually you have to make a choice, because you don't want to just be stuck in discussion forever. You're like, well, we're going to go with this, A because of this, or maybe you actually invite those two engineers to do proof of concepts on a small level to say, okay, well, if you think yours is better for this reason, let's test it out and see, and give them half a day to see if that's true, which one's true. So enabling people to help prove their points in real demo ways, I think is really, really valuable, because a lot of times just out of that, they realize, oh yeah, your way is way better for whatever reason, and they end up figuring it out with each other. Other times I think I will get feedback from people that it's like, okay, well, that's good to know, but I don't think that that's necessarily something that's going to stop us from kind of going on to the next. We can say that's an open question or an open thing to solve. It shouldn't block us from moving forward. So thinking about ways to I think you're going to have to always evaluate, is this feedback you want to accept and take it in and add it to the design, or is it something you want to accept and maybe table for later, or you want to reject it because it's either out of scope or it's just going to take us down a path that we don't want to go to. But you can still, I always document it. So I always say, hey, this was other options or other ideas that other people had, and these are the reasons why we chose not to go with them. Because at some point it may come up again, like, why did we decide to go with this option over this other option? So just include it in the document. I think is super helpful, so people know why you chose what you chose in the end too.
All right, thank you.
Hi, Amber.
Hello.
I was curious, what is compensation like for architects compared to other roles in engineering?
That's a great question. I think it really depends on the company. I think typically architects will make more than engineers, although there's probably really, really high level of engineers that would make more than architects. So a lot of times it's a continuation of an individual contributor kind of career path. And so oftentimes it's seen as a more senior role than a senior engineer. So I would say at your company, a senior engineer would be compensated a little bit less than an architect. And markets are going to be different too. So I don't want to necessarily throw out numbers because I think they definitely depend on the market.
Amber, if you don't have any prior experience in an architect role and you want to switch over to an architect role, and maybe you've just done a bit of, maybe small scale designing for really mini projects, how do you showcase that to companies who are looking for someone with prior experience?
Well, I mean, we all start with no experience at some point. So when I first applied for my first job as an architect, I thought about all of the things that I had actually architected, because we didn't, where I had worked, had an architect. So that work was being done by me. I had to show basically, here are all the, I had to think about it and say, here are all the things I designed and here are the things that I did as the architect in that functional role on the team, and really showcase those things that I worked on. And the other way to, if you're trying to do it at a company that you already work for, is to some of the things that I mentioned earlier, which was to try and do a stretch assignment or to start designing like documenting the current architecture of your system and sharing that out with people, and then proposing kind of future states and architectural direction and strategy for your team. Just kind of take that on if you don't already have somebody in your area, and then use that as your experience. So just like when you're fresh out of college, you don't have necessarily a job experience, but you have all that experience from college or maybe an internship, and you're listing out all of those things that you did work on, even if it was, in a different capacity.
Yeah, sure. Also, another question was, when you're building out an app, and this is like a new app, you don't have any preference as such for it. How do you decide on things like a response time or an SLA and stuff like that?
I think that's a great question. I think that there's probably some, I would say some like best practices out in the industry based on what it is that you're building, as well as it's going to be very specific to what it, like what it is that you're building. Is it like an internal company facing app that shares like the cafeteria menu? Probably you don't need as much uptime and performance as something that's like high performant customer facing, right? So it's going to depend on what the application is. So I would say that for like a consumer facing type of application, I see 200 millisecond response for services being kind of a standard. For web page loads, there's a lot of great information about how anything really longer than 2 seconds like causes conversion and other revenue driving numbers to drop. So you want to look at things also not just from like an individual service response, but holistic. If you're dealing with web pages or mobile responses, really how you measure that is going to be different as well. So you want to think about from your consumer's perspective, what does it look like?
Perfect, thanks.
It's going to be unique to your situation.
So I think we're out of time. I'm going to snag the last question if you don't mind. Do you have, so I'm sure some architectures are better suited for different types of problems. Are there any like resources or cheat sheets where you can just kind of see them all, sort of like event driven is good for this, maybe like pipelines tend to be good for like these sorts of problems and solutions?
Yeah, so I'll do a little self-promotion because I wrote a blog article on Medium about exactly that. And so I talk a lot about the different types of architecture patterns. If I put up on the screen there, Medium, it's at AD Milavec. And it was, I think, not the last one, but the one before that, maybe, the last blog article I posted. So feel free to check that out. I think that's a good place. where I tried to do like a really summary of the ones that I showed on that list earlier, and some real examples of each one, when and how and why you might use it, from a hopefully a pretty high level. So I'm going to tell you to look there first, but I also find that if you do some searches, there are some other great examples out there of people who wrote some great articles about architectural patterns as well.
Great. Okay. Thank you so much for speaking today.
Thanks. And one last thing. Can I say one last thing?
Yeah, go for it.
All right. And this is just I am hiring. So if you are interested in working with me, we are actually looking for a security engineer, and we have one listed for New York City, which is a remote position. So if you're in New York City, please still apply. If you're looking for a job as a security engineer, you can visit our careers list. There's a link here. I'd love to connect with all of you no matter what, and keep this conversation going. So thank you so much for having me today, Cindy.
Thank you.
Thank you.